get started. So in this warm-up, I just took a snapshot of a proof from your textbook. So notice I didn't type this up myself. It's straight from the textbook. But I thought it was a good proof because it's proving something that we use every day in this class, in this unit. It's proving the Triangle Sum Theorem. Now, parts of this proof we haven't learned, so that's why those parts are filled in. Don't worry about that. But we just want to fill in the parts that are empty. All right? So, given triangle ABC, so that's what we're given. Now, we haven't ever done this in a proof, but the first statement tells us to actually draw a line. So we're going to draw line L through point B, and we're going to make it parallel to AC. And that's a parallel postulate. We didn't necessarily learn that, but like I said, doesn't matter because it's filled in. All right, so now that we have that parallel line, now we can say things about some of the angles. So let's fill in the blanks. The measure of angle 1 is equal to the measure of angle... Can you see angle 1? It's hard to see, guys. Measure of angle 1 is equal to the measure of angle 4. And the measure of angle 3 is equal to the measure of angle 5. And what's the reason? This is the most important part. Yay! Good job! It is the alternate interior angle theorem. That is the reason we're allowed to say those are congruent. Okay, so now we've said that those are congruent. Now, we can do angle addition and the definition of a straight angle, that all the angles add up to 180. So we're going to add angle 4 plus angle 2 plus angle 5, and we're going to say that it equals 180. Well, that's pretty straightforward. No one has a problem with that, right? Those three angles add up to 180. Angle addition and definition of straight angle. Okay, cool. So now we're going to, well, I don't want to say the answer. So now we're going to say the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180. And the reason is it's not a geometry postulate, it's just an algebra postulate. The reason is it starts with an S. We can't say triangle sum theorem because that's what we're proving. It's just an algebra property. It starts with an S. We took this number out and we took this number out, and we substituted something in for it, right? Angle 4 equals angle 1. So we can remove angle 4 and we can substitute angle 1 in. Okay? Angle 5 equals angle 3, so we can take out angle 5 and we can substitute angle 3. So the reason here is just substitution. Substitution and transitive get mixed up a lot, so from now on in this class we're just going to use substitution and we're going to keep it nice and easy. So we're not going to use transitive anymore, we're just going to keep it to substitution in our class, okay? So, whatever, we proved the triangle sum theorem. Fabulous. Alright, let's check last night's homework. It was a long homework. Hopefully most of the problems didn't take that long, but it was a very long homework. Check your answers. Okay, so we're taking a look at number 18. There we go. This is one that has multiple triangles. 17 does as well, and you'll definitely see this on quizzes and possibly the test. So let's go over our strategy of how we would work this. Now, the only way that this one works is if you have a shared side. Well, we do. We have a shared side. And that shared side has to be the smallest side of one triangle and the largest side of another triangle. If it isn't, then we wouldn't be able to answer this question at all. But we made sure to design the questions to where they work this way. All right, we're going to start in the triangle that looks the smallest. We're going to start in the smallest triangle. So we're going to start right here. If you didn't start in the smallest triangle, you would figure it out, so you would stop and you would start over. Okay? Now, we're going to find the missing angle. Do y'all have those ready for me? The missing angle. So obviously, y is the largest side in that smaller triangle. So let's list them from least to greatest. Okay, so the smallest side would be x. X is across from 34, so we're going to list that first. The next largest side would be w, across from 42. And within this small triangle, the largest side would be y. What I didn't say yet is that you can never compare sides of one triangle to sides of another triangle. You can't say, oh, in this triangle it's across from 34, oh, in this other triangle it's across from 28, and try to put one before the other. You just can't do that. The only one we get to use twice is y, because y is in both triangles. So you would never compare a side of one triangle to a side of another triangle based off of the angles, because the angles don't determine the side. It's just a relationship. It doesn't tell us how long the side is. It just tells us the order of the length of sides. That probably didn't make sense. All right. We left off on y. We left off here. So that better be the smallest side of that next triangle, of this triangle right here. So obviously if we find the missing angle on this one, 122. So y is the smallest. The next largest is z. And the largest side is v. So what I'm trying to say here is that z is longer than w, even though z is across from 30 and w is across from 42. Do you see what I'm saying? You can't compare angles when you're in the green triangle and the blue triangle. That is the correct order. You have to work in one triangle alone and then skip over to the other triangle. Okay. Neil, I didn't have 17 on my original thing. I'm going to keep going, okay? Here we go. I'm going to work this one really quickly, but this is old stuff that we've already learned in this one. Let's start by, were we given any information? We've got parallel lines. That's helpful. Oops. You always start with what you're given. And we're given two angles. We're given this, and we're given this. So we can do a lot with that. First, if these lines are parallel, see that they're parallel? That's 90. That makes this 90. It makes this 90. That transversal is going to be perpendicular to both parallel lines. So now that we know that angle A is 90, 90 minus 22, 180 minus 90 minus 22. Triangle Sum Theorem will give us angle B. So angle A is 90, angle B is 68. We use the Triangle Sum Theorem to get it. To find angle A, I used corresponding angles. I love how many theorems are in this problem. Okay, now I'm going to use the linear pair theorem to find C. So the linear pair of 68, 112. Now I'm going to use alternate interior angles to find D, 112, 112. Where can we go from there? We can do linear pair theorem again to find E, which would be 68 there. Now we're going to use the isosceles triangle theorem. Isosceles triangle, well, we'll do isosceles triangle theorem. And we know that these two are congruent because those are the base angles of an isosceles triangle. They're the base angles. So I can do 180 minus 68 divided by 2. So F is 56. They're both 56. 56, 56. Now I can use the linear pair theorem to find G. 180 minus 56, 124. And then I can use alternate interior angles to find H. Man, that was a good problem. Okay, 23, and then we'll move on to the lesson. List the sides from shortest to longest. So you picked another one where there's two triangles, so we're going to get plenty of practice. All right, 23. Remember, we always start with the triangle that looks smaller, the one where the sides look shorter. So we're going to start in this triangle right here. The shortest side is across from 50. So the shortest side is MQ. The next shortest side would be QP. And the longest side, you know the longest one is always going to be the shared side. That's how it has to work. The longest side is MP. Okay, now we're going to switch focus and we're going to work with this triangle. The shortest side is MP. So we're starting where we left off, which is how this problem works. The next shortest side is NP, and the longest side is MN. So you begin in one triangle, you start where you left off to make it to the other triangle. Yep, good, Kendra. So that last one, they used a weird word. You were asking why the answer to that one couldn't have been 5.000001. You thought about the answer really well. You did correct there, but it did say it had to be an integer. Integral means like an integer. So it had to be what integer, is greater than 5. You need to pick the smallest integer that's greater than 5. And that's why that one is 6. I don't really have time to go over that one, but that was a good problem. Title your notes. If you still have this thing that we've added to a couple of times, you can get this out. If you don't still have this thing, it's not a big deal. You can just write it in your notes. But if you did still have this document from earlier this year, we've already filled in 1 through 7. So we're just going to add to it, and we're going to do number 8 today. We've already done 1 through 7. Okay. Let's do a review first, because all these words get kind of confusing if we don't keep going over them. State the converse and inverse of the conditional and state the truth value. There's a lot of words in that. Let me decode it for you. First of all, let me remind you that a conditional is an if-then statement. Okay? If it is cloudy, then it will rain. So that's a conditional. The converse is when you reverse and the hypothesis and the conclusion trade places. They switch places. The hypothesis and conclusion switch. That's converse. Converse, reverse. Converse, reverse. Inverse is the not. If not hypothesis, then not conclusion. All right? Yes, logic and reasoning notes if you found that. Yes, it is. Okay, if a triangle has an obtuse angle, then it is an obtuse triangle. Is that true or false? True, right? That's the definition of an obtuse triangle. True. So what's the converse of this sentence? If it is an obtuse triangle, then it has an obtuse angle. And you know I'm writing shorthand just to get through the lesson. If you had a quiz, you would write out every word, okay? If it's an obtuse triangle, then it has an obtuse angle. Check. True. And now let's write the inverse. If a triangle does not have an obtuse angle, then it is not an obtuse triangle. So just be careful when you're writing the inverse. You put not on the original. Be careful. You're doing it to the original. And this one's also true. They were all true. No, you don't have to write it down. We're just practicing what we've already learned this stuff. I'll tell you when to write something down, okay? Okay, let's go over this one. If ABC is equilateral, then the measure of angle B is 60. True or false? What do you think? Neil, I can't go back or we won't get to the quiz. I cannot. Maybe after the lesson. True. Very good. If ABC is equilateral, then the measure of angle B is 60. The converse is, if the measure of angle B is 60, then ABC is equilateral. Is that one true or false? So remember, when you're trying to determine the truth value, try as hard as you can to prove it wrong. Try to draw a picture that proves it wrong. If you can prove it wrong, then it's false. And we could definitely prove this one wrong. I could draw a picture of a triangle with a 60-degree angle. Is that triangle equilateral? No. I just proved it wrong. That's called a counterexample. And so it's false. All right. The inverse. If triangle ABC is not equilateral, then the measure of angle B is not 60. True or false? It's also false, and the counterexample is that same exact picture, okay? Both false. So the sentences, all the related conditionals, aren't always going to have the same truth values. We're actually going to find out which ones are always going to be the same. It's a cool pattern, okay? So hold on to that. Here is the first thing you need to write down of today. You're either writing it down here, on here, it is number 8, or you're just writing it down in your notes. It's number 8 on the logic and reasoning notes. The contrapositive, practice saying that out loud to yourself. It's kind of an intimidating word. The contrapositive of a conditional switches the hypothesis and conclusion and negates both. It switches and negates. Switches and negates. That yellow is hard to see. I apologize. So if the original is if P, then Q, the contrapositive is if not Q, then not P. So the contrapositive is like a hybrid. You all know what a hybrid is? It's like a combo. And so the contrapositive is the converse and the inverse all wrapped into one. It's the converse and the inverse. Okay. This is just a summary. I just wanted to show you what they all looked like. You do not have time to write this down. Let's see if we can practice writing contrapositives, okay? Let's just say the contrapositive of each of the following. Ready? If a team scores the most points, then they win the game. Okay, we're going to switch and we're going to put not. If a team does not win the game, then they did not score the most points. Get it? Let's try another one. If you do not wear your ID at Cy Falls, then you go to the office. Contrapositive. If you do not go to the office, then you were wearing your ID. This is a big deal. When you do a not, it turns, they cancel, they're gone. So if you do not go to the office, then you were wearing your ID. Okay? If a triangle is equilateral, then it's equiangular. Contrapositive. If it's not equiangular, then it's not equilateral. Good? Yes? Show me thumbs up. Okay, we're about to conclude that. I don't want to say that yet. I want to do this first. Okay, we're getting near the end because I know you'll need to take your quiz. We are going to write all three, and then we're going to come to a conclusion about the pattern of the truth values. Let's do the truth value of the original. If lines do not intersect, then they are parallel. True or false? False. The counterexample is, of course, the famous skew lines. Okay? Now let's write the converse. If lines are, if lines are parallel, then they do not intersect. Totally true. That's one of the different definitions of parallel lines. They do not intersect. True. Inverse. If lines do intersect, then they are not parallel. Totally true. If they do intersect, intersecting lines could not be parallel. Okay, let's do the contrapositive. If lines are not parallel, then they do intersect. That one's a little bit harder to get right away, but it's going to be the same as the original. Skew lines is going to be the counterexample. If lines are not parallel, they could be skew. And it's saying they do intersect, but I found ones that didn't intersect. This, guys, is not a coincidence. This is going to happen every time. So the original and the contrapositive are going to have the same truth value. The converse and the inverse are too. But I wanted you to see that the original and the contrapositive are going to have the same truth value. Please write this down in your notes. Then, okay guys, next slide. Ooh, what is the first word on this slide? Dun, da, da, da. Prove. So we are getting closer and closer to starting to write proofs ourselves. We are exposing you to them as often as we can. All right, let's prove a theorem that you're going to use on the quiz today. Let's prove the exterior angle theorem. So we know the exterior angle theorem says the measure of angle 1 plus the measure of angle 2 equals the measure of angle 4. Well, let's prove it using theorems we already know. All right, the first statement. We're going to say that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180. Why are we allowed to say that? What theorem allows us to say that? Yes, the Triangle Sum Theorem. And you guys have a list of theorems, and you're welcome to use that list of theorems as you're getting used to the reasons. Angle 3 and angle 4, this is what we're going to say next, is that these angles are supplementary. Why are we allowed to say that those are supplementary? Good. Linear pair theorem. Awesome. Now I need to say something. I didn't tell you what you're going to say next, but the reason you're allowed to say it is the definition of supplementary. So we've said angle 3 and angle 4 are supplementary. What comes right after that? Right after you say they're supplementary. Good. Good. Now we're allowed to say the measure of angle 3 plus the measure of angle 4 equals 180. We have to actually state that because not everyone knows that that's what supplementary means. Why are we allowed to say that? Because the definition of supplementary. Okay, the next one I went ahead and did for you. Angle 1 plus 2 plus 3 equals 3 plus 4. I simply substituted. That's all I did. Do you see how both of these equal 180? You see this? So I just substituted in 3 and 4 for that 180. Just trade places. All right, and then finally, when we subtract from both sides, see, we can cancel this out from both sides. And what's left over? The measure of angle 1 plus the measure of angle 2 equals the measure of angle 4. And that is the exterior angle theorem. So we just proved the theorem starting with the triangle angle sum theorem. All right? Okay, let's do one more. Given the measure of angle 1 is 115, the measure of angle 3 is 60, got my degree symbol, prove that the measure of angle 4 is 125. All right, so we need to use theorems and work our way over to angle 4. We're probably going to use the theorem that we just proved on the previous slide. All right, the measure of angle 1 is 115. What's the reason? It was given to us. 1 and 2 are supplementary. Hey, we just used this on the last slide. What's the reason? Good. Linear pair theorem. All right, we already know what goes here. We used this on the last slide. Measure of angle 1 plus the measure of angle 2 equals 180. That's the definition of supplementary. I did the next step for you. If you put angle 1 in, 115, and you subtract from both sides, you will get, subtract, the measure of angle 2 is 65. We subtracted to get that. The measure of angle 3 is 60. That was given. We didn't find that. That was given to us. So now we know the measure of angle 2 plus the measure of angle 3 equals the measure of angle 4 by the exterior angle theorem. Remember, that's our shortcut theorem. The 2 plus the 3 equals the 4. The remote interior angles, their sum equals the exterior angle. And finally, if we substitute in what they all equal, we get that the measure of angle 4 is 125. We knew 2, we knew 3, we just substituted it in, so that's why that was substitution. So we got to our final destination. All right. Yay, proofs. Okay, I have 2 more slides. If points A, B, C, and D are coplanar, then they form a convex polygon. Draw a counterexample. Do we remember what those words mean? I used them a little bit on day 1, and then we haven't talked about them since. So, would this be a counterexample? Nope, because I did what it wanted me to do. I did 4 coplanar points, but they formed a convex polygon. Yeah, I want one that's not convex. So that would be a counterexample. 4 coplanar points that do not form a convex polygon. It's concave. Very good. Last problem. If a polygon is regular, remember that means all sides congruent, all angles congruent, then it is convex. Is that true or false? This one is kind of a hard one. If it is regular, it has to be convex. It has to be. You can't have a regular polygon that looks like this because all the angles need to be congruent. Well, this angle, that angle is like a reflex angle. That one's greater than 180, and we don't even study those angles. So to be regular, it has to be convex. So that's true. What about the converse? If a polygon's convex, then it's regular. Is that always true? Good, Jane, good. I can have many, many polygons that are convex, but they're not regular. The inverse, if it is not regular, then it is not convex. Also false, because if it's not regular, it could be convex. And then, just like Jane said, I told you that the original and the contrapositive always have the same truth value. So we can talk about the contrapositive, but we know these 2 are always going to match, and these 2 are always going to match. That's pretty cool. Every time. Promise. Okay. Take your quiz and work on your homework that kind of looks like English homework after your quiz because you're writing sentences like crazy.